Good morning, students. This is virtual class of physics, and today's topic is work in different thermodynamic processes like isothermal process, adiabatic process, etc. First of all, work done in isothermal process. We know that work done dW is given by this formula PdV. We have proved this formula. dW is equal to PdV. So, if work is done by the gas on the piston in isothermal process and volume of gas is increases from its initial value V1 to its final value V2, then work done will be W equal to integration V1 to V2 PdV. And we know that by ideal gas equation PV is equal to mu RT. So P equal to mu RT upon V. So we can write, suppose that this equation first, by using equation first we can write W equal to integration V1 to V2 mu RT upon V dV, and mu R is constant, and for isothermal process T is also constant, so constant will be taken out from the integration mu RT integration dV upon V from V1 to V2, and formula of the integration dV upon V will be log natural V. So we can write W equal to mu RT log natural V from V1 to V2, or it can be written as W equal to mu RT in bracket log natural V2 minus log natural V1, or we will write mu RT log natural V2 upon V1, V2 by V2 upon V1 we can also write. So this is the required formula for work done in isothermal process. We can change this log natural into log 10 base by using the formula by multiplying 2.303 to this formula of work done. Now work done in adiabatic process. Again, if the volume of gas is increased from its initial value V1 to its final value V2 in adiabatic process, then work done will be W equal to integration V1 to V2 P dV. Again, using Poisson's law for adiabatic system, we know that P1 V1 to the power gamma, which is equal to P2 V2 to the power gamma, which is equal to constant. Suppose that this constant is denoted by C, or we can also write P V to the power gamma equal to constant. So we can write P equal to V to the power gamma minus 1, V to the power minus gamma into C. Substituting this value, suppose that this equation first, second, substituting this value in equation second, we will get W equal to integration V1 to V2 constant C V to the power minus gamma dV. Constant will be taken out and by using the formula of integration x to the power n, this formula of integration, you can note down integration x to the power n dx equal to x to the power n plus 1 upon n plus 1. So using this formula, we can write C V to the power minus gamma plus 1 upon minus gamma plus 1 from V1 to V2, or W equal to constant C upon 1 minus gamma in bracket V2 to the power minus gamma plus 1 minus V1 to the power minus gamma plus 1. After substituting the upper and lower limits, we will get W equal to constant upon 1 minus gamma. If we multiply by this constant, so you can see earlier constant C equal to P1 V1 to the power gamma, which is equal to P2 V2 to the power gamma. So in first term, in right hand side, having V2 to the power minus gamma plus 1, we will take C equal to P2 V2 to the power gamma, and in second term of right hand side, having V1 to the power minus gamma plus 1, we will take C equal to P1 V1 to the power gamma. Now see, after multiplying by constant, we will get W equal to 1 upon 1 minus gamma P2 V2 to the power gamma multiplied by V2 to the power minus gamma plus 1 minus P1 V1 to the power gamma multiplied by V1 to the power minus gamma plus 1. So by calculating, you can see V2 to the power plus gamma power will be cancelled out by minus gamma power, and V1 to the power plus gamma will be cancelled out V1 to the power minus gamma power. So positive powers, positive plus 1 powers of V2 and V1 will not be cancelled, so we will have W equal to 1 upon 1 minus gamma in bracket P2 V2 minus P1 V1. So W equal to 1 upon 1 minus gamma in bracket P2 V2 minus P1 V1 or it can be written as W equal to 1 upon gamma minus 1 in bracket P1 V1 minus P2 V2. This is the required relation, and we can also term this formula as W equal to 1 upon gamma minus 1 in bracket P, in place of P1 V1 we can write RT1, and in case of P2 V2 we can write RT2. So W equal to R in bracket R upon gamma minus 1 in bracket T1 minus T2. This is also the formula of work done in adiabatic process. Now work done in isochoric process. Isochoric process. You know that in isochoric process, throughout the process, volume remains constant. So we can say that dV equal to 0 for isochoric process. So work done W equal to P dV, which is equal to 0. So for in isochoric process, work done will be 0. Now for isobaric process, you know that pressure is constant. So work done will be given by P V2 minus V1 or delta V or dV. It is also right, W is equal to P dV, W is equal to P delta V, or W is equal to P in bracket V2 minus V1. Now cyclic process. Work done in cyclic process. You know that cyclic process is the process in which a thermodynamic system returns in its fundamental state after passing through some different states. So in this state, in this process, state of the thermodynamic system remains constant. And you know that internal energy of the system is state variable. It depends only the state of the thermodynamics. So if state is constant, is same, so delta V will be 0. Delta V, delta U will be 0. Sorry. Internal energy, change in internal energy will be 0 because internal energy is constant due to its property of state variable. So by the first law of thermodynamics, delta W will be equal to delta Q, because of, you know that by the first law of thermodynamics, delta U equal to delta Q minus delta W. Here delta U equal to 0, so we can write 0 equal to delta Q minus delta W. So work done delta W equal to delta Q or W equal to Q. So for cyclic process, heat given to the system converts into work. It does not increase the internal energy of the system. In our next video, we will discuss about the numerical problems of this chapter. Till then, keep watching. Thank you.